In this video, I will show you uh, this the style how to write code for embedded roulette simulator, which having the number of push button, yeah, and LED, and also buzzer, as well as these multi-segments. But we are using the most left and the most right for two variables. Later we will put it, and then the project specification is uh, during power up, right? During power up, let D1 toggle every 500 millisecond. So when while all other LEDs remain off, two variables are initialized to 0, right? And their values are displayed on 4-digit 7 segment display, with one variable shown on the left and other ones on the right. Then when the S1 is pressed, the LED pattern like this will display at 250 millisecond intervals. Simultaneously, two variables continuously, that two variables continuously generate random number and display with one variable on the left and the other on the right. And then when S1 is released, the random number generated by two variables are displayed on for segment as well. And its number must be limited to a range of 1 to 6, yeah? 1 to 6, and all LEDs are turned off. If both, and then if both variable equals 6, the buzzer will sound 3 times with each beep lasting 1 second. If both variables are equal but not 6, the buzzer will sound twice with each beep lasting 1 second. And then else the variable differ, the buzzer will sound once for 1 second. And after the buzzer logic completes, these all three logic completed, the system revert to the power up mode. So let the one again be toggle and all others will be off, right? So we need the push button, latch, buzzer, and also the multi segments, right? Actually, we are using the Arduino multi functions board, right? There's a test on it, but I don't have it. I just write the code for that. Okay, first we go to the clock configuration, and then I set this one to say to 60 meg. Okay, because I'm going to use the APB2 timer or timer 11, right? I'm going to use the timer 11. So I go to the timer 11, activate. Then after I activate it, then I have the parameters to be set. Yeah. Okay, so this we need the the oh no, we need the timer formula. So the timer is here. For the time delay of 4 milliseconds at APB of 60 meg. So if the PS is set to 3000, for example, right? So we have 80 PR of 80, right? So now I can set that to, okay, so this one at 80, right? PS 3000 minus 1, and then I have this one 80 minus 1, and then no divisions, and then enable. Is it correct? Yes, no division. 3000, 80, 60 meg. That's all for the parameters, right? 3000 up 80, and then enable it. So that's all for the uh, for the timer. Okay, now we go to the I/O. So we need the push button P1, PE4, PB0, and then we need PE5. Okay, I will set the PE6, PE7, and okay, 1, 2, 3, yeah. Then I need PB6 and PB3. All this I will set first because of I need to set them to GPIO. Okay, so click to System View and GPIO, then go to the PA6, set to Open Drain, PA7 Open Drain, and then PB3 Open Drain, and then PB6 Open Drain. So we have 1, 2, 3, 4. Okay. 1, 2, 3. Okay. 4, 5. Okay, right. 5. So PA5 no need. Just set it to the output push pull. Then go back to pin out view and set PE8 for the output, P9 for the output, and PB5 for the output. Okay, all these three is really for the multi 7 segment, right? 1, 2, 3, PE8, PE9, and PB5. So that's all. Then generate code. Then from here, you go to the core. Right? And then we prepare the driver that we need is that 3 driver. Okay. So we need multi-landing, let's switches and user tick. So we move them to the include subfolder, then move all that C to the source, right? Then after that, then include all them. First one, found inc control space double quote user control space enter, found inc control space double quote multi-segment control space enter, found inc control space, and then LED and switches. Okay, all that 3 we include them. Then after that, okay, we have the handler here, timer 11. So first of all, I will solve the 7 segment, right? I mean the timer, right? Okay, for the 7 segments, yeah, we need to first, we don't want the this leading 0, no need, right? Just forget it. Okay, we can off them, right? Okay, so we go here, on off. Okay, so we have that segment. We on the first one on segment, and then we off these 2 of segment. Same with this off the segment. Then the last one we need to on. Okay, so we on only that 2. Then later we can update them with the variable if you don't want, if we want, right? So assume I have a variable here. Okay, the variable can be any number. So I use int16 underscore t, right? So I have the sorry, it's not here. So PB. In the PB, then I type uint int 16 underscore t. Okay, so I have the number. What number is that? Say I have no, I have 2 variables. Variable 1 equals 0, and then I just let it there, and then variable 2. Right, I have 2 variables. Okay, that's 2 variables. Okay, I can put it here in int 16. Okay, or in int, it can be in number, because I'm going to what we call to random it later. Right, so just after that, then I will add both them together, so I can write down yeah, so the main variable x, I call it variable x. So I can see that variable x is equal variable 1 multiply with, well, if I have number here, I multiply by 10 is here, by 100 is here, then by 1000 it will be here, right? So I multiply with 1000, and then I plus with variable 2, right? Then I just update it. I just update the segment and convert it to segments variable x. Okay, but remember variable x, this convert number must be in uint16. Okay, so we need to to convert it from int to uint16 variable x. So we update it. Simple. That's all for that. Then we need another thing that we need is the timer. And we need to on the timer. All team base start. Okay. So we need the start IT as team 11. So after that, then we need to go back to the go to the driver. Okay. Source. Find out timer. Okay. List down outline. Learn them. Oh, you can go to window, to view, and then outline. Then find out the period elapsed. Okay, yeah, no, this DMA timer period elapsed. Go back, copy this one, then go to the main and place it here. Yeah, place it somewhere here, in here, begin 2, begin 0. So you can type if steam, if that timer, what timer is that? Team 11, then we can, yeah, multiply the segment, and then we call multiply segment. Okay, so we settle down that one, the first one, nothing. Then after that, then we need the yeah, in this time I will use a simple technique. Yeah, so I will set a C-stick use. I just use one only. So I have one only. Okay, later. Okay, right. So I have if get C-stick. Okay, number 0. I can set this one at each at 10 millisecond. It's 10 millisecond, right? Okay, so here I can I can set it to get tick 0, 10. Okay, no problem. Then switch. Then I use the mode. I say state. I say state 0. So I have state now. I'm using state. Okay, so I have a case 0, and then break. Right. So I have a state. That right. Then copy this one. Enter and enter and enter. Sorry. Okay, so here you see, this is size 1, I think. Yeah, it's size 1. So let's say this one at state 0, this one at state 1, right? No, it's 2. Okay, say this one at state 0, set 0. So when we press a button, then it will jump to state 1. Then when it is released, then it will jump to state 2. Then after that, then we go to state 3. Then it jump back to state 0, right? Okay, so we have 0, 1, 2, 3 state. Okay, 0, 1, 2, and 3 state. Okay, so here in the first case, state 0. Okay, copy. So I can put a state here, right? No problem. int8 underscore t equal 0. So when it started, then it straight go to state 0. So here you will wait for the push button, right? Wait for the push button, right? Now the first thing is you will toggle the LED for every 500 milliseconds. So each 500 milliseconds, we can do something like something like if, right? We can use the loop, right? The loop inside it. Okay, so we have a loop. If loop, or let's say loop, is plus loop greater than 500, then loop equals 0, right? So the first time when it comes, right? So loop equal to 0. When loop equal to 0, then we start to toggle things, something like, okay. So when it started, right? When it started, okay. So we can see that when it started, then it will reset. Okay, here 500. When the system is for while all other LED is remain off. So here we can see that each 50 times of 10, right? Plus 50 times 10 loop become 0. Okay, that's the first thing. Okay, we can set that. We can set it to the first time it's happened, then loop become loop become anything else. We can set that if state 1 is not that equal to state 0, right? Then we see that loop equal 0. Okay, loop equal 0. And then we copy the state. Don't forget to copy it. Copy the state. State 1 equal to state 0. Okay. So we need to have another thing here, the state. State 1. Okay. So and then ensure that the state is not similar when it started. So we can set it to any number other than 0. So 1, for example. So here, if the state not equal to state 0, then state 1 equal to state 0, and then loop equal to 0, right? Then we do whatever that, then we do whatever, okay? If loop equal to 0, okay, then Allah Akbar. Okay, then first thing we will toggle every 50 milliseconds. We toggle the LED D1. LED D1. LED D1. And then here variable 1 and variable 0 must be set to 0. Okay. And then we convert them for display, right? Because it's the first time it's happened. Okay. And then we can write down here if loop equal 0. Right? If equal to 0, then we toggle. Then we toggle the LED. Right? From here we can see that. Okay. Two variable, yeah, this one, 500 milliseconds. System for while all other LEDs have been off. So we will toggle it, right? Toggle it. So we can toggle the LED by just, okay, because we have already the LED driver there. So we can use any value, say buffer UINT 8_t LED buffer equal 0, right? It's set to 0. So same thing happens here. So copy and set it here. And then when it's happened, then we toggle the LED, right? Toggle the LED. So we can SO with 0B 0001, right? Toggle the last bit. And then update the LED. Let display, we update it with LED buffer, right? LED buffer. So we toggle it. So as time comes, then it will then we increase, and then we increase. If a plus loop greater than 50, then loop become 0. So it will keep on turning here, right? And then this one is controlled by this, right? Control this. So when it becomes 0 again, then it will do this again, we do this again, and do this again, and again, and again. Okay, so that's the first one. Okay, there are many ways, by the way. Okay, there are many ways. And next, then we check for the push button. So we're looking for only one. Okay, so I love to use something like UINT8_t, okay, SW1, which is yesterday, previous. SW0 is equal to 0 now, right? Now. So here we read the SW1 from SW0, right? Copy the previous one, that 10 milliseconds previously. Then SW0, we read the new one, right? We get a switch. Get switches, right? Then if SW1 is equal to 0 and SW0 is equal to 1, then O0 B001, right? This one is 0 B000, right? Nothing press. Then we change the mode, the state. So state 0 equal to 1. Okay. So again, each 10 millisecond, this one will be called. So as state is 0, so this one will be this case 0 will be executed. And then if that is the first time happen, then it will memorize and set the loop to 0. Okay. Then copy the variable, right? Copy the variable to 0, and then convert it become to be displayed for the first and last segment, and convert to 7 segment representation, and then off. they turn off the LED. You can set it to 1 if you do like 0B 0001. Okay, so you see this bit will be toggle later, become 0, and then come back, become 1, come back, become 0. Each time the loop out, right? The loop out, loop become 0. And then this one, if we increase the loop and then check if the loop greater than 50, if the loop greater than 50, then the loop become 0. So for the next, for the next one, then it will execute this again, and we execute this one again. And then each 10 milliseconds, then it will check push button. If being pressed, then state change to 1. Right? State change to 1. So now in the 1. So now in the 1, the first thing first, the 200 millisecond, right? The LED we toggle, right? So we have 4 pattern, LED pattern, right? So I place it first here, PB, constants, UINT8 underscore T, right? So I name it as array, whatever array equal right. Then we place this one 0B as well as this one, as well as this one and this one. Okay, so we have 0B blah blah blah. We have 3, and then next let's see, because this is only one array that we have in this code, right? Yeah, the only one array that we have. So I name it array, and next I need index. So I name something index int8 underscore T index idx equals 0. Or I can let it be, right? Just index it, because I have the previous and present state to set, right? So I copy this one. So in state 1, first thing first is we don't have index, we don't have loop, right? So we can set index to 0, and then this one no need, right? No need. I just take this one out, right? So the index becomes 0. Okay, so next index becomes 0. So it's 200 millisecond, 200 millisecond. Then we will change this. All right. So I can say that index is equal to 0 if okay, now we use again the loop, right? The loop equals 0, because loop we're going to use as a timer, right? So if loop equals 0, so what we do then, we will we will update the LED display will be whatever in array that pointing by the index, and then we can increase the index, right? Then we can increase the index if index idx plus plus index is greater than the size of array minus 1, then we can see that index equal to 0, right? So we settle down that one. So that only for the array. And next we need to randomize the what we call, we need to random the variables. Okay, so that variable we can random using this as random and random function, right? This one, right? Okay, so we can use this one. Okay, So we can as random, right? So we need the seeds, right? As n, and then okay, we need the seed. So I put one seed here. int seed. Name it as seed, right? Name it seed. So each time it comes, then we render it. We render it that seeds or unsigned int unsigned. So seeds. Okay. Maybe you can plus it if you would like, random it and plus it. Okay. So this one should be int 8, 16. And precision seeds, right? So we random it here, as you can see here, int unsigned int underscore seeds, right? Void, right? This one, right? And then after that, then we call the variable one is equal to see, random it again, right? Random percent k percent, as we need 1 to 6, I think 1 to 6. So we random it's up to 6 here, 6%, 6, yeah, random, and then divide by 6. 6 become 0, 0 become 5 become, oh no, 6 become 5, right? Variable 1 is equal to random 6, 5. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, no. 0, 1, 2, 3, 4, 5. 6, right? Random 6, percent 6 mean if that number is 0, 0, 1, 1, if 2, 2, if 3, 3, if 4, 4, if 5, 5, if 6 becomes 0, 7 become 1, right? Become 1. 7 become 1, 6 becomes 0, right? So 1 to 6, so 1 plus random 6 equals 1 to 6. Copy, and then again for the variable 2, right? Random it and update it, right? Random and update. So this is to random the number. This is to set the seeds, the set for the random. This is randomized process. Then after that, then we displayed it. Right? We displayed it to the, so we can change that and convert and display. Right? Convert and display. So here variable x equal to variable 1, whatever here, multiply by 1000 and plus with variable 2, then we feed it to the convert to 7 segment, right? uint. Why I use uint, variable x? Oh, because int. Okay, this one I can set it to no need. This one I can set it to, because this one is as random is uint. uint. So need for us to typecast it, right? Typecast it. No need. Okay. And again here. Right. So if the loop, if plus loop greater than 25, then we set loop to 0. Right? To 0. Okay. Okay. So that is what we have in for the second one. For the second one. and then when it is released. Okay, so here we need to monitor. Okay, here we need to monitor the push button again. So I copy this one that I copied it. Sorry, I love to copy it. So if the switch previously is 1 and now it is 0, right, then it's 0, then state change to 2, else it will not change. So here you can see that I combine both them together, right? So here is the okay lah, right? I think you can see it. So this one is to handle the state, right? Same with this, right? And all top is what happened in the state. This is happened once only. This is also happened once only, right? And then this is repeatedly. This two is repeatedly happen because we can have that cases. Okay, next, then we jump to the second one. When it is released, then random number generated by 2 are displayed on server segment. Okay, that one on it for us to check to do it. Okay, with one variable on left. Okay, because okay, it's directly changed here, jump here when we release, and whatever we see that we see. Each number is limited to a range of 1 to 6. Yeah, we already set it here. So 1 to 6. 1 plus random percent 6. So any number, if the number of multiple of 6, 6, 12, and so on, then it becomes 0. So 0, for example, so numbers such 0, 1, 1, 2, 3, 4, 5, then become 1, 2, 3, 4, 5. Right? So 0 plus 1 become 1, and then 5 become plus 1, then become 6. So we have 1, 2, 6. Yeah, 1, 2, 6. All LED are turned off. Okay, so in this case now we need to off the LED. So copy this one first. This thing. So we need to off the LED. Right? Off the LED. So off the LED is simple. Just okay. I don't know either we going to use a loop or not. Okay, no problem. It's okay. Just let display equal to 0, turn off. Okay, then what we do next? Okay, that's all. The random number generated by 2 variables are and all that are turned off. That's all. Enough. And then from that, then we can jump to buzzer logic. Buzzer logic. Or we can set it there, or jump straight to buzzer logic. Okay, so if we want to jump to buzzer logics, right? So just after that, then we directly jump to state, right? State 0 is equal to 3, right? So we just do that one and then jump, do that and jump. Okay, all right. Next, we go to the last state. If 4 variable equal 1, 2, 3, 4. Okay, so we need to do this one first. Three of that. Okay. So we have 2. All right. So first of all, we need to have this one. Okay. Okay, now now we start to check, right? Check if, right, variable 1 is equal to 6 and variable 2 is equal to 6. Then we set something, say loop, right? Loop equal what? Loop equal 6. Loop equal to 3. Okay. else if variable 1 is equal to variable 2. Okay, because you see that if both variables are equal but not 6, so it can be 1, 2, 3, 4, 5. Okay, and then they said loop equal 2, and the last one else loop equal 1. Okay, so we settle this one. Now we're going to do that what's that buzzer sound, right? That buzzer sound with each bit lasting for 1 second. Okay, buzzer. Okay, I forgot it to off the buzzer, and when we start we better we off the buzzer. So type buzzer is off, right? You can write down off, I think. Yeah, we are off there. Okay, because I already put here the multi-learning on off, you know, in the LED, the LED. Just check it. Okay. Yeah, off, on, here, this one. So you can off it, and then okay, then we start to on and off, right? On and off. So for the first one, say this one is a bit tricky how to do it. Okay, we can set up some sort like say we have the we name it as start, right? Start case 3 equals 0, right? So we have start case 3. Again, we can use bool here, right? You can put it here, bool start case 3 equals 0. Okay, then we can type here if start case equal 0, right? Or if that's start case, if not start case, then we on the buzzer, right? On the buzzer, on buzzer. Else if, okay, sorry, this one when we start it buzzer on, then we toggle. Okay, then after that, then else if start case 3. Okay, buzzer off, and then okay, then toggle it, okay, sorry, I will change this loop to any other name because I'm going to use that loop. So I said loop equal 0. Then I change this one to count. Count equal 3. Count equal 3, 2, and count equal 1. Okay, say that. Just set it first. So this one, if loop equal 0, then we will check the start case. Start case. So if the start case is equal to okay, so we toggle it. Then if loop plus plus greater than, if loop plus plus is equal to greater than 1000. Okay. 1 second. 1 second. 1 second is 1000. 1000, then loop equal 0. Okay, loop equal 0. So this one actually handle this one. So each time it come, then it will become it will either do this or do this. So we must multiply this by 3, by what, by 2. Okay, so on and then off. Okay, on, off, on, off, on, off, on, and off. So 1 second on, 1 second off, 1 second on, and 1 second off. For how many? For number of count, right? So each time it's happened, then it will drop, right? So it will drop the what? Drop the count. So count minus, right? Count minus. So if count equal 0, so we can say that it's on, then count become 5. Okay, we go to the count equal to 2. Okay, count was on, then count become 1, right? Then it come back. When it come back again, right? So the count still 1, not 0. So come back again. Then when count become 2, no, sorry, then it will off, then count will drop. So you cannot see that off. So we see on, off, and straightly we go up to the mode 0 zone. Okay. Alright, so count equal to 0, then it will state equal to state 0 will be 0. Okay, so here let me check again. Okay, so when it come to state 3, first thing first, then it will set the state case to 0, right? And then loop will be set to 0. So when loop equal to 0, then this will be executed, right? And then it will determine the number of count. So because we have on and off, so the number of count should be double, right? Double 3 times, so it should be 6. 2 times should be 4, right? And then 1 times should be 2. Then it will on. Okay, it will on because loop equal to 0, and start case is not start case. Okay, so buzzer on, then after that, then okay, buzzer on, then then it will invert this one, and then count to minus minus. Okay, if you see here, both them are doing the same thing. So what you can do, copy this one, later we place it here, right? Okay, then and invert that state case 3, then count minus minus, so from 2 become 1, become 1, so it will not change state, not change state, and then okay, and then loop increase until 1000, then it becomes 0, so this one will become true, and then the buzzer will be off. Once the buzzer off, then counter will decrease to 0, so then it will jump straight to state 0. Okay, so that's all for the code. I think it's okay. Okay, but then when it jump back to no, is it, yeah, when it jump back to here, then it will set again to 0. Here, all right. Okay. That's all, I think. Okay, now look back to the code, the first one that we have here. Okay, we include all the driver we need: user text, multi-learning, 7 segment, LED and switches. Then this is the variable that we need, right? We have seeds, we have variable 1, variable 2, variable x, state 1 we set it to 1, and state 0 we set to 0. Remember, state 1 must be set to any number other than state 0, and then let buffer we set to 0, and we don't care actually. This one don't care, right? We don't get it, right? Then switch 1 and switch not equal to 0 is to mimic, right? To that the push button never press before, right? We can set it here too, right? Where we use the push button, right? We can place it there. And then index, no need to set to initialize the value. Constant UINT array, the one that we want to display. So we will have 1, 2, 3, 4. Then we set the start case to 0, right? Start case, we use bool, and then off the buzzer. Then remember, okay, another thing that we have here, once it is it jump back to state 0, this is better for us to ensure that, right? Ensure that the buzzer is off. Right? Buzzer is off. Okay. Now the first case, so here we display to the to 7 segment 0 0, right? So we set this one to 0. Then the LED, we're going to toggle the last bit, and the last bit here, each 500 millisecond, because 50 multiply with 10, so we toggle it. Then after that, then if we check the push button, if the button is being pressed, then we jump to state 1. This is state 1. In state 1, then we start to update the array, this one, right? Array. And then after that, then we increase, we random the number, variable 1 and variable 2. From this one is from 1 to 5, and 1 to 6, 1 to 6, right? Then we multiply it with 1000 for the left side, and the right side just we take whatever that we have, added them, then convert the number to 7 segment and display it. So this happen each 250 milliseconds. Then at the same time, is 10 milliseconds, we will check the SW1, the push button, if that push button is being released. So if it is released, then we jump to state 2. So in state 2, then we ensure the LED off, and then straight we jump to state 3. Actually, we can do this here. We can do it here. Then in this state 3, but it takes only 10 milliseconds. You can see it. Then in state 3, what we do is we set the start case to 0, the bool, and loop to 0, right? And then we check the variable. If the variables equal to 6, both are equal to 6, then we set counter to 6. Else, if variable is equal to that variable 1 is equal to variable 2, any number 0, 1, 2, 3, 4, 5. If set 6, then counter equal to 4. Else, counter equal to 2. So this means that the variable are not equal, right? Then in the loop, when the loop is equal to 0, then we start to either on the buzzer or off the buzzer based on the start case. So if the start case is 0, then buzzer on. If start buzzer is 1, then buzzer is off. Then we toggle the start buzzer here, and then decrease the counter, sorry. Then this one just to increase the loop and for 1 second, because its loop its increment. Oh, sorry, this one should be 100, should be 100. 100 multiplied by 10 is 1000. And then if counter equal to 0, right? When we decrease the counter, then counter becomes 0. Then state will change to 0, and buzzer we ensure the buzzer is off, right? Buzzer is off, and break, right? And break. That's all the codes. Bye bye.